Hello children, so we'll continue with trigonometry. So today we'll learn about trigonometric functions. Okay, from the previous class, you know, in a circle, if O is the center and O is the radius R and AB is the arc length S and the angle separated by S here at the center is theta, then arc length is S equal to, we got r theta. Okay, S equal to r theta. We derived this formula in the previous class. So if S is equal to r theta, then theta will be equal to S by r. Now what you see here is that, you know, theta is in radian measure. Okay, so theta is equal to, suppose this is S by r we have. Suppose r equal to 1. Suppose you have a unit circle, okay, and radius is 1. Okay, then this will be theta. Okay, then this is, okay, so if r is equal to 1, then theta will be equal to, in this case, S. Okay, so S is a number here. It's a length. It has some magnitude. Okay, S is a length. It's a real number. So that means theta can be taken as a real number. Now, if we suppose this arc length to be x, okay, to be x, then this angle, then theta will be equal to, in that case, theta will be equal to x. Okay, so now in place of writing, you know, sine theta, cos theta, okay, so when theta is in radian measure, we can write sine x, cos x, etc. all ratios. So now, where x is a real number, any real number, okay, so this sine x, this trigonometric ratios can be taken as trigonometric functions now, because the value of sine x depends upon the value of x, so it can be taken as a function. So now onwards, so sine theta and sine x are more or less, it's the same thing. Okay, so now what we write, we take these trigonometrical ratios as trigonometric functions. All right, so instead of sine theta, cos theta, now we write sine x, cos x, etc., where x is a real number, x belongs to r. Okay, now here, as I told you, if you take a unit circle here, okay, 1, then suppose this arc length is x, okay, then in that case this angle also can be taken as x, okay, because theta equal to, you know, theta equal to S by r. So if S equal to x, then r equal to 1, then theta will be x. So you can see theta is also equal to x. So instead of sine theta, you can take sine x, cos x, etc. All right, now suppose the point P here, the arc length AP is x, the point P has coordinates AB. So this is center. Suppose O is the center. Okay, if you take the axis, x axis and y axis, and O is the origin, okay, then suppose this OA, this is x axis, this is y axis, so this is origin here. Okay, AB are the coordinates of P. Then, you know, sine x, you know, sine is, some people have P by H. So coordinates AB means this y coordinate is B and x coordinate is A. A is x coordinate, B is y coordinate. So y coordinate is B and x coordinate is A. So sine is, some people have, that is B by 1, that is B. For all x belongs to R. For any x, sine x equal to B. Similarly, cos x equal to, cos is, you know, B by H. So base is here A. So A by 1, that is equal to A for all x belongs to R. Okay, these are the fundamental or basic trigonometric functions. Okay, so other ratios can be obtained using these two, like cosec x is equal to, you know, 1 by sin x. So cosec x function is 1 by sin x. Okay, similarly sec x is 1 by cos x. Alright, tan x is sin x by cos x, and cot x is cos x by sin x. Okay, so we can get all the 6 trigonometrical functions. Now let's take first one, relations between t functions. This one, relation between t functions. Okay, so relations between trigonometric functions. Okay, now you know sin x is equal to, you know, 1 by cosec x, and cosec x is equal to 1 by sin x. They are reciprocal functions. Okay, now next you have cos x is equal to 1 by sec x, and sec x is equal to 1 by cos x. Similarly, tan x equal to 1 by cot x, and cot x equal to 1 by tan x. Okay, these are relation between t functions. Now we take the fundamental identities, very, very important, fundamental identities. Fundamental identities. Now you know this identity is sin square x plus cos square x is equal to 1. Okay, so from here we can derive some more identities. Sin square x equal to 1 minus cos square x, and cos square x equal to 1 minus sin square x. Okay, then number 2, 1 plus tan square x equal to sec square x. Number 2, part 1. Part 2, then tan square x equal to sec square x minus 1. Okay, and number 3, sec square x minus tan square x equal to 1 by transposing the terms. And the third one, third part 1, 1 plus cot square x equal to cosec square x. So this will give you cot square x equal to cosec square x minus 1, and number 3, cosec square x minus cot square x equal to 1. Remember, sin square plus cos square is 1, sec square minus tan square is 1, and cosec square x minus cot square x also 1 for all values of x. Okay, now we'll see some applications of these relations. Now we'll take some questions now. Okay, so now this one is from exercise from this ML Logworld, exercise 3.2. Exercise 3.2 from ML Logworld, some questions. Okay, you can find these questions there. Okay, now number 1, 1 to 6 we have to prove. So let's take question number 1. What we have to prove? What is given? Cos x upon 1 minus tan x minus sin square x by cos x minus sin x equal to cos x plus sin x. Now you have to prove that, okay, these two sides are equal, or you have to prove that this is equal to cos x plus sin x. So when you have to prove, okay, you can take left hand side and get what is there in RHS, or you can take RHS and get what is there in LHS, or you can simplify LHS, get in the simplest form, then simplify RHS, get in the simplest form, and show that two sides are equal. Here we can simplify left hand side, so we begin with left hand side. Okay, so write as it is, 1 cos x upon 1 minus tan x minus sin square x upon cos x minus sin x. Now when we have sin x cos x, then change other ratios also in the form of sin x cos x. Like we have tan x, change tan x into sin x cos x. Okay, you know tan x equal to sin x by cos x. Okay, that's using formula. So we can write this as cos x upon 1 minus, what is tan x? Sin x upon cos x, minus, write this as it is, cos x minus sin x as it is. Now here if you take LCM, okay, you get cos x upon, if you take LCM here, LCM is cos x, so if you multiply you get cos x minus sin x minus, you get sin square x by cos x minus sin x. Okay, now this cos, if you change division into multiplication, then this reciprocal denominator, you have to take the reciprocal, isn't it? So this cos will go up. So cos x into cos x will be cos square x upon cos x minus sin x. So here sin square x upon cos x minus sin x. Okay. So if you take LCM here now, LCM is cos x minus sin x. So numerator, because denominators are same as LCM, so numerators will come as it is. So you get cos square x minus sin square x. So here it is in the form of a square minus b square, and you know the formula, a square minus b square is a plus b into a minus b. So you get cos x plus sin x, a plus b, cos x minus sin x, a minus b, divided by cos x minus sin x, and here cos x minus sin x can be cancelled. So what is left here? Equal to cos x plus sin x equal to RHS. So this is proved. Okay, this is how it can be proved. Now let's take another example. Question number 2. Question number 2. We have 1 plus cos x 1 minus cos x root over is equal to cos x plus cot x. We have to prove. So here also we'll begin with left hand side. What we have? 1 plus cos x 1 minus cos x root over. Okay. So here see, there is no square root sign. Okay, so that means we have to remove this square root sign. So how we can remove sign? If we can express this as a whole square. So suppose you have a square root over, so square root cancel root, so you get only a. So if you have to remove square root, then you have to express this expression in terms of whole square. So to get whole square, what we do, we multiply by 1 plus cos x. Okay, root over 1 plus cos x. So under root you within the root you multiply. So 1 plus cos x into 1 plus cos x, and here also 1 minus cos x into 1 plus cos x. You have to multiply both numerator and denominator by same expression. Okay, so we take the opposite sign of the denominator here, 1 minus cos x, 1 plus cos, so that you can use a plus b, a minus b formula, and you get whole square here. So you get 1 plus cos x whole square root over, and here 1 minus cos square x, because a plus b into a minus b is a square minus b square. So this is equal to 1 plus cos x, and you know 1 minus cos square is sin square x. Sin square x. Now since this is also whole square, this is also sin square x. So you can write as a single whole square. So you get 1 plus cos x upon sin x and its whole square under root. Now this square will cancel this root. So what is left? 1 plus cos x by sin x. Okay. But if you see RHS, there are two terms. So we'll separate. Okay. So 1 plus cos x by sin x you can write as 1 upon sin x plus cos x upon sin x. So 1 upon sin x is cos x and cos by sin is cot x. So equal to RHS. So it is root. Okay. Cos x plus cot x. Now we take the other one. Next question. Question number 3. Here it's given sin to the power 6x plus cos to the power 6x is equal to 1 minus 3 sin square x cos square x. So we have to prove. Again LHS. Okay. So this one you can write as a cube plus b cube form. That is sin square x whole cube plus cos square x whole cube, because 3 2s are 6, 3 2s are 6. We can write in the form of a cube plus b cube. So it is in the form of a cube plus b cube. Okay, so a cube plus b cube formula is a plus b whole cube minus 3ab into a plus b. This is the formula, a cube plus b cube. A plus b whole cube minus 3ab into a plus b, where a is equal to sin square x, b equal to cos square x. Okay, so applying the formula, a plus b means sin square x is a plus cos square x is b and whole cube, minus 3 a is sin square x, b is cos square x, a plus b is sin square x plus cos square x. So sin square x plus cos square x, you know 1, so it is 1 cube minus 3 sin square x and cos square x into sin square x plus cos square x, again 1. So what you get? 1 cube is 1 minus 3 into 1 3. So 3 sin square x and cos square x equal to RHS. So it is root. Okay, so number 3. Now question number 4. Question number 4. We have tan x upon 1 minus cot x plus cot x upon 1 minus tan x is equal to 1 plus tan x plus cot x equal to 1 plus sec x into cosec x. So there are 3 expressions. So first expression, second expression, third expression. So what we do, we'll begin with the first, get the second, and we begin with second and get the third one. Okay, so here we don't write LHS, RHS, so we write first expression is equal to tan x upon 1 minus cot x plus cot x upon 1 minus tan x. Okay. So here 1 minus cot x is there, here 1 minus tan x is there. Okay. So we can change this into better what to do, you change into sin cos and then you can simplify and get that one. Okay, it will be easier. So this will be tan x is sin x by cos x upon 1 minus cos x by sin x plus this will be cos x by sin x, cot x is cos by sin, 1 minus sin x by cos x, tan is sin by cos. So if you take LCM here, so what you get here, directly we'll do, here numerator you have sin x by cos x into, now change division to multiplication. So LCM will go up, so that means sin x will go up, and here you get sin x minus cos x, because LCM is sin x minus cos x. So when you change division to multiplication, this sin x will go up and sin x minus cos x will come down. Similarly here you have cos x by sin x into, the LCM is cos x, which will go up because changing division to multiplication. So you get cos x minus sin x. Okay, so here what we get is sin into sin will be sin square x upon, you get cos x into sin x minus cos x, plus here you get cos square x upon, here you see here is sin x minus cos x, so here cos x minus sin x. So we can make it sin minus cos by changing this sign, meaning we take minus sign common from here, so this becomes minus, this will become plus, and plus divided by minus will be minus. Okay, so what you get, sin x, and then you get here sin x minus cos x. Okay, now if you take LCM, then you get sin x cos x into sin x minus cos x. So here you get sin cube x, because if you divide you get sin x into sin square by sin cube. Here if you divide here, sin x get cancelled, this cancels, so cos x, cos into cos will be cos cube x. Okay, now use a formula once again. Okay, so I'll erase this part here. Now this is the second expression, that's what we are going to get. So this one will be a cube minus b cube formula. Okay, you can use factor formula. A cube minus b cube is a minus b into a square plus b square plus ab. So a cube minus b cube is a minus b, then a square plus b square minus sin x cos x, divided by, you get sin x cos x into sin x minus cos x. Okay, so a cube minus b cube is a minus b into a square plus b square plus ab, a square plus ab plus b square, that's the formula. So this sin x minus cos x get cancelled. So you know sin square plus cos square is 1, plus what you get, sin x cos x, divided by, you get sin x cos x. Okay. So this will give you if you separate it, okay, to get this one, what we do, first we try to get this expression, so we keep one as it is here, formula sin square x plus cos square x, because there are three terms here, so we write as it is. Now we separate, because we try to get the second expression first. So this is sin x cos x. Okay, now you separate it. So if you divide by sin square x by sin x cos x, you get sin x by cos x, sin square by sin x cos, one sin will get cancelled, sin by cos. So cos square by sin x cos x, one cos will get cancelled, so you get cos x by sin x, and sin x cos x by sin x cos x, you get 1. So what you get, 1 plus sin by cos is tan x, and cos by sin is cot x, equal to second expression. Okay, second expression we got. Now from second expression we try to get the third one. So therefore second expression is equal to, we have 1 plus tan x plus cot x. So 1 plus tan x is sin x by cos x, and cot x is cos x by sin x. Now if you take LCM, then it's okay, 1 is already there, you have to get sec x plus sec x cos x only, so we take LCM of these two only. So 1 plus LCM is sin x cos x, so this will be sin square x, because cos x will cancel, so sin into sin, sin square, sin cancel, so cos into cos will be cos square x. So 1 plus, this will be 1 by sin x cos x equal to 1 plus 1 by sin is cosec x, and 1 by cos is sec x equal to third expression, because it is 1 plus sec x cosec x, so cos x, it's the same thing. Okay, so this is proved. Okay, so now we'll take the last question today. That's number 5. Okay, question number 5 up to here. Question number 5. So 1 plus cos x plus sin x upon 1 plus cos x minus sin x is equal to 1 plus sin x by cos x. So what is it? 1 plus cos x plus sin x upon 1 plus cos x minus sin x equal to, we have 1 plus sin x upon cos x. So LHS. Now here what we do, we first divide throughout by cos x. Okay, because here you have cos x in the denominator, so divide by cos x here. So what we get? 1 by cos x plus 1 plus sin x by cos x divided by 1 by cos x plus 1 minus sin x by cos x. Okay, so this will give you 1, you can write first, okay, or you can write 1 by cos x is sec x, and sin by cos is plus tan x plus 1, you get denominator, you get 1 by cos is sec x minus tan x, sin by cos is tan x plus 1. Okay, now see, in the numerator we try to cancel this denominator, okay, later on. So we write formula for 1 here. You have to remember this step. Instead of 1, you write the formula in terms of sec and tan. That is sec square minus tan square is 1. So we use that formula. So we have sec x plus tan x plus, we write sec square x minus tan square x, whose value is 1. And denominator we write as it is. No, because we need to cancel this. Minus tan x plus 1. We need to cancel this, so we keep it as it is. Now idea of writing this is, now we can factorize. You can use a square minus b square formula. So what we get? Sec x plus tan x plus, we can write in bracket. Here we get sec x plus tan x into sec x minus tan x using formula, whole divided by, as it is, sec x minus tan x plus 1. Now you can take sec x plus tan x common. So if you take it, what you get? Sec x plus tan x common. So what is left here? Here is 1, then plus sec x plus tan x you have taken common. So what is left? Sec x minus tan x, and here also you have sec x minus tan x plus 1. Now if you look at these two expressions, 1 is positive, sec is positive, tan is negative. So these two are same expressions, so we can cancel the whole expression. So what is left? Sec x plus tan x. But we have in the RHS sine and cos, so we change sec and tan into sine cos. So sec is 1 by cos x and tan is sine x by cos x. So if you take LCM, we get cos x, okay, cos x, and here it will be 1 plus sine x. So we get 1 plus sine x by cos x is equal to RHS. Okay, so it is proved. So we take the remaining questions in the next class. Okay, thank you.